So Fabian is again on stage to talk about Stereo. So you don't want to miss that. And then we have Otto as the product manager for NDS to talk about the roadmap and the plans. So yeah, interesting title, why we decided for Stereo and not for Protobuf. And so happy to have Fabian explain the benefits on that. And yeah. Please.
Okay, thanks. So hi and welcome back. So yeah, we are asked many times, why don't you use for serialization? Why don't you use Google protocol buffers? Of course, one would say, yeah, because I've heard different answers. I can already, before I start, I can tell you there was one which I would never give, but I received one from one of the members. Hey, because we don't always want to use something from Google. We also want to do it ourselves. No, anyways, so this is something I'm going to talk about now, why we did this. And let's start with, because it's actually two questions, right? What is Zereo and why we decided to use it? So what is Zereo? So there's one thing in today's conference which I haven't really heard about, all that buzz and fuzz about generative AI. And nobody has talked about this yet. So let's bring it in. So I couldn't resist, to be honest. So let's ask beloved ChatGPT, what is Zereo? So when you do this, it gives you a very good overview. So if you only came for the summary, maybe you want to remember this slide and you can take a nap or coffee or anything. So it does a pretty good job in answering this. First sentence, it says Zereo is a data serialization language and runtime library designed to facilitate blah, 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 blah. Okay. So if you don't want to read all this, just listen. I'll tell you as well. So, so yes, Zereo is a data serialization mechanism or something. So what is serialization? What does it mean? So in computing, we say, so this is from Wikipedia, serialization is the process of translating data structures or objects from one in-memory object. We serialize it to some form. We put it on a disk, data carrier, put it over the air, whatnot, put it on a different computer, basically, maybe running a different operating system, a different, reading it with different software, whatever, we deserialize it. And then we get the exact same in-memory object back. So this is what serialization is all about, right? And this is what Protobuf and others, and so also do in Zereo as well. So in the automotive context, that can be map generation, traffic messages, some car status messages that need to go from one ECU, from one cloud computer, whatnot, to another one, right? And so it goes over the wire, over a network, it goes via the cloud, whatever. We put it in packets, we serialize it, and we deserialize it. What is important in our context, it needs to be programming language agnostic, platform agnostic, and it needs to be type safe, because we, of course, in that transfer don't want to make any errors, and yeah, and an X comes out as a Y. So in general, serialization mechanisms, there are two types of those. There are textual serialization and binary serialization. Textual serialization, some very well-known formats are JSON, XML. You see some examples where they are used in the automotive or in the geolocation context. For binary serialization, there's a huge list. Here are some mentioned, and the ones in red are the ones we talk about today. One is Protobuf, originated from Google, and Zereo originated, or actually started to be maintained longer from NDS. A little bit of history, it was not an NDS invention. It was actually taken from a university professor who came up with it in the 2000s somewhere, and we back then took it over. It was then first internally RDS, called Relational Data Script, and then later on called Zereo. So before we're looking at any we're only focusing on binary serialization mechanisms today. So what are important features of binary serialization mechanisms? First of all, we need a contract and some documentation so we can look at things and see that, because binary, you know, it's simply, bluntly speaking, it's zeros and ones. We don't see anything about it. So we need some, what is called a schema definition language, an IDL, which documents which bit, which byte means what, right? So this is what all the binary serialization mechanisms have. The textual ones don't need that, right? Because you can read it. It's text, you can simply read it. We need to be able to evolve the schema. It needs to be platform agnostic, as I already said. It needs to be programming language agnostic. And we want to have strongly typed data structures so that it's not everything. A one is not a string one, but it's simply an integer or unsigned integer or something like that. So we exactly know what to expect. It should be compact, because if compactness wasn't the game, then why use binary? Because then you could go to textual representation. So this is one of the key aspects. But in addition, we also want something for debugging purposes that is human readable. So like a certain representation, maybe that's not the one representation we transport over the wire, but for debugging purposes, it's of course nice to have a textual representation of the binary object and not only the zeros and ones. So asking another question, why NDS decided for Serio? So let's ask ChatGPT again. Why is NDS Association using Serio? And it gives us an answer which is quite lengthy and good, and it brings up things like compactness, gets flexibility, there's language independence, basically everything what we already said about a binary serialization mechanism. So it goes on, says it can generate code, maintainability, extensibility. But basically, if you do the same thing for Protobuf, if you ask, why is NDS Association using Protobuf? I mean, it's not like super intelligent. It's a generative AI. It's good in text, right? It gives you nearly the exact same answer, because it does know, okay, I read so many things about binary serialization, and these are all valid for both. So let's see why we actually decided for Serio and not Protobuf. But before we go into the details, you've seen using a lot of generative AI. I think someone spotted it that also the images were generated, right? So they were generated with, I mean, everybody knows ChatGPT, but maybe some of you also know Midjourney, which is also an AI giving you images based on prompts. So why did NDS decide for Serio and Protobuf? Thought like, okay, ask another AI. So this is generated stuff. So one is Serio and the other one is Protobuf. Guess who is who? So the prompt is Serio and Protobuf. Guess why we decided for Serio? No. All the machoism aside, a little bit of history why we did that. So in 2008, when NDS actually started the NDS Classic development and the maintenance goes on, there was actually no open source protobuf available. So you see protocol buffers. So I said something wrong. So actually we started before 2008. And in 2008, protobuf was open sourced. So actually it came too late. That's the thing. If it would have been there, probably would have been a good candidate, and I wouldn't hold this kind of session at the moment, because we then would simply stick with it and would be happy with it. That could very likely be the case. So, but a matter of fact, we had to find something different. And the solution was data script, and we enhanced it to what is called a relational data script, short RDS. So you will still find this in the Git repositories in NDS, for instance. In 2018, we did a re-evaluation, because that was the point when we started NDS Live. We said, okay, NDS Live, that would now be the chance to see, shouldn't we do it in Protobuf now, maybe? Or is RDS data script actually better? So we did make a re-evaluation. You will see some of the numbers that I'm showing today are from what we have today, but back then they were similar. So there were reasons to decide to stay with DataScript. Actually, we had to rename it because that name was already given. The NDS EV decided to open source it completely on GitHub again. Because until then, between 2006 and 2018, it was just an internal development. But now it's open source under BSD3 license, which also was the original license of Mr. Godmar Beck, university professor from the US somewhere. And we actually, I think Marcus Juncker once reached out to him asking whether we can do this, and he said, yeah, go ahead, or something like that, I think was the answer. Didn't care much about his old work from 20 years ago. And since then, the NDS EV is also the maintainer on GitHub of Serial. So let's see why we decided for Serial. So when you're looking at serialization mechanisms, there are a couple of key performance indicators you look at, and you make the comparison based on those and not based on how Midjourney would render the name, right? So first is features, because features boils down, is this future-proof and extendable? We have the quality of code. Is it usable, for instance, in functional safe system? We've heard this, all the HD maps and all the functional safe systems, is they usable there? Of course, data size, because data size boils down to communication costs on the mobile network, or even in the cloud, because it's traffic in, out of the cloud. Maybe not storage. If you're looking simply at storage, you don't care much about all the costs of storage nowadays. But whenever you're moving something around, whether it be from in and out of cloud or onto the mobile network, then somebody is standing there and you need to put dollars in. So, and last but not least, very important as well, encoding and decoding speed, because that boils down to user experience and system load, which the latter one, system load, easily transfers into higher BOM costs, right? Because then you need a bigger CPU. If everyone is using the CPU heavily, you have to spend 3, 4, 5 euros more, which is a couple of millions if you scale and roll it out. So it's also a very important KPI here. So let's take a look and compare Protobuf and Serio based on these KPIs. So just for the records, we took Serio 2.10.0 and Protobuf 3.21.9. So just the versions. Looking at the features, we see both are language agnostic, platform neutral, both have a schema IDL, both have basic data types. Serio has a little bit more than Protobuf. Serio has bit level data types, so it allows you to go below the byte borders. It has both have compound data types, so you can generate complex schemas. Serio, in addition, has something like templated data types, which you can reuse, like templates that, like you know them from C++, for instance. And also, Serio has a built-in delta compression for integer lists, which is not available in Protobuf. Both have a service interface definition, part of the feature set. Serio, in addition, has not only services, but also publish subscribe definition. In Serio, you can do constraints in the IDL directly. So in the schema, you can already write during schema definition time. The integer should always be between 0 and 100, even if the range could be more. But you said in your documentation, this is percentage from 0 to 100 with 1% steps. And you can then simply write this constraint in, and the generated code will automatically check it for you. This gives you the opportunity to already write some basic checks in that you later don't need to write test code for it in addition. In supported programming languages, Protobuf is out there for a lot longer and has of course much wider adoption. So it's literally available for each and every programming language you can think of. Serio is only available for C++, Java, Python, and Go. Both have debug string representation and JSON. So you can both, in both ways, say load a protobuf file and generate JSON out of it to read it. The same goes with Serial. Funny enough, you can easily actually convert between the two using this JSON representation because they're very similar. So if you know how to, and also the IDL structures are very similar. And so this is actually how we did the tests that I will later show. So we simply said, okay, use something that is encoded in Serial or in Protobuf and then make JSON out of it and convert it into the other one. So it makes it quite easy to go there. And for schema evaluation purposes, Protobuf has the edge here as well. So it has a wire format that actually Serial doesn't have. So the schema evolution possibilities are more limited in Serial than in Protobuf. Let's put it like this to not go into too many details. When looking at functional safety, we did part of the analysis was also that we found, okay, Protobuf has some undesirable features for functional safe systems. For instance, you can see the list. There are some default values generated in the code. So basically, if something in the stream is missing, the generated code will simply say, okay, I give it a default value. So the reading application will not be able to validate, was that really meant to be like this, or was this is this now generated as a default value? Right, only because it wasn't in the stream. So in Serial, if it's not there, or if anything is broken, it simply crashes, and you know, there wasn't some things were not as expected. There's also enums are not treated consistently across languages. There is a backwards compatibility implementation, which is good if you want to evolve such schemas. But it could be that it's just truncating numbers, and in terms of whether now you hit a pedestrian or not, or the car goes into a safe state, only because of this is probably something you don't want. So you don't care too much about backward compatibility, but more for functional safety. Then these things are not so easy. So these features in general make it actually harder to validate whether the data was meant to be like this. If Serial finds something in the data stream which is not according to its schema, it simply says it's an error. I can't work with it. And so from a functional safety point of view, we think that is a little better than fixing it more or less conveniently on the reader side, which may be for many other applications that may be beneficial. Looking at the quality of code, we did a static code analysis using Clang Tidy. Here you can see the results and numbers. Both don't have any critical items. It's not like that Serial is already completely, let's say, issue-free. But in general, you see Protobuf has more issues to fix. So if you want to use it, if you are very strict on it, you have to invest more into Protobuf to get that as if you would have in Serial. So we're currently also, and this is of course one big advantage by maintaining it ourselves, is we can more easily fix it. We don't need to fork Protobuf, fix everything, and then they make an update. We need to do the whole thing again, and so on and so forth. So at the moment, test coverage of Serial is line coverage is around 98%, branch coverage around 90%. The ultimate goal is to reach 100% on both, so that we have 100% line and branch coverage. But yeah, we're getting there. So there are NDS members actively contributing to make Serial ASIL ready, which is very good, and we highly appreciate that. And so this means in terms of quality of code, it goes to, I would say, also a little bit to Serial, but a little bit up to you to make a decision here. When we're looking at data size and encoding and decoding speed, we actually checked a couple of different data sets to be fair, right? To play fair. used openly available. First was the address book, which is the example from the Protobuf website. It's actually a string and integers mix. It's very minimalistic, right? It's an address book. There's a name, there's a phone number, and there's the information is the phone number, mobile phone, home phone, work phone, or something like that, right? So it's not really complex. So it is really minimalistic, has a minimalistic complexity. We used the Apollo Auto HD map format, which is naturally in simply written in Protobuf. We took it, we wrote an, so that goes now for all of those. We took the Protobuf schema, we wrote a corresponding serial schema, and then we did this JSON import export magic that I already explained. We did the same for the Mapbox vector tile format, which mainly consists out of strings, has a few lists of basic complexity. I forgot to note that the Apollo HD map is mainly floats, enums, has many lists, is of intermediate complexity, I would say. And then we took the general transit feed spec, used to be Google Transit feed spec, is about this public transport schedules and real-time thing, which is mainly also a good mix of strings and integers, but leans towards more strings. Actually has a few lists and is of intermediate complexity. And then, so these were all available in Protobuf, where we wrote a zero schema for it. And then we also took the liberty to do it the other way around and took the NDS Live Lanes module from the HD, NDS Live HD module, which is mainly integers, many lists, is kind of like advanced complexity because it's deeper nested. And but this one is actually using the full zserio-Feature set, right? We have to be fair there. There, of course, something like if we only need 4 bits, then we would write in 4 bits, right? Even if you would also need only 4 bits in the Apollo HD map, which is in Protobuf, we have still like an integer there and so on and so forth. So we did also for this comparison not optimize the other formats. They can be optimized, but we didn't do so. Good. When we're looking at data size, for the address book, Zero is roughly 14% smaller. For Apollo, it is 20% smaller. For vector tile, 10% smaller. For GTFS, roughly 28% smaller. For the NDS Live Lanes, it's about 80% smaller. Of course, this is the reason when you have this very compact schema already, and there is no representation of, like, say, a 3-bit or 4-bit data type, and the only thing so you can make out of 4 bits, the next smaller one in Protobuf is 4 bytes, which is the UINT32. I mean, this of course, this is where these numbers come from, right? Because simply these features were not possible to do so. Wait a second, I'll pass the mic. I throw it, you turn it on. Then you have to turn it on first.
So for NDS Live Lanes, it's understandable because Zero is optimized. Yeah, but others, you say you didn't optimize, but still it's smaller size. So yeah, how you explain
so that? The smaller size basically comes from having, for instance, this what I call the wire format, yes or no, right? Because what Protobuf does, it is not simply taking what is written in the IDL, and it's not one-to-one in the stream, but it adds additional information, right? Especially to be backwards compatible and so on and so forth, but also to be able to do the default values, yes or no. So there is additional content that you don't see when you're looking at the schema, right? And Zero doesn't have that. And that usually is a little bit more for integers or enums. And this is why they're also a little bit different, right? For strings, it's basically the same information. So if you have something heavily leaning on strings, like we said, see the vector tile, there's the least difference, right? But if we have something where it's more in integers, floats or so, the internal representation in Protobuf is different. So that's what this kind of, it's not, Zero is like what you see is what you get. encoding, so you can really see. So you can even open a hex editor and check out the first bytes if they are defined like this. In Protobuf, this doesn't work out of the box. So this is mainly the reason for this. When we're looking at the parsing time, so this was only for reading, not for writing. Zero is 15% faster, or it took 15% less parsing time. On Apollo, it's 35%. On vector tile, and now you see when there are mainly strings inside, the decoding is on both. They're both on par, right? Same goes for GTFS. GTFS had a couple of more integers, but it was not. But the heavy lifting is basically done on the strings, and this is where then where they're both kind of the same. And for NDS Live lanes, it's still 24% smaller. The difference here is, of course, there we have this advanced complexity using the list compression. And in Apollo, we didn't have. So Apollo map is bigger, and also, but in Zero, then also faster. So, so these are the bare numbers. And in the end, as a summary, I can say, NDS has chosen, to answer the question from the beginning, NDS has chosen Zero instead of Protobuf because it is smaller, it is faster, it allows more advanced schemas, it is ASIL ready, and of course it's under NDS control, not to forget that. And you can find it on zserio.org or on GitHub, and yeah. Any questions? That's basically why we decided for it. Ah, dinosaurs waking up.
Mark. I was not talking loud enough. Was more curiosity question. Do we know what other fields is using Zero next to us?
No, we don't. So at the moment, we do not know who else is using Zero. We do know when we're looking at when we looked at the stats that we had in GitHub, right? You can see who is starring or forking your repository. Then you can look at the details. Who is starring that? Is this person somehow related to an NDS member? We can strike him out. But there are some where we couldn't do this. So there may be some people using it for something, but we do not know of a bigger user. Yeah, it's open. We're managing it totally on GitHub. So if there are some requests, but there are also sometimes requests from, let's say, NDS related or map related space where people are asking something there. But yeah, it's openly available. But we haven't really got feedback on the usage much. So it's still kind of like unknown. Yeah, ChatGPT, we need to feed them more information and tell them which is the best, so that it actually tells people, hey, maybe when you're looking for Protobuf, you should also look into Zero. Good. Are there any questions? Oh, Boris has another question.
So maybe I missed it. Did you also, the results for size, they are compressed, both compressed or non-compressed?
No, they're both uncompressed.
And if
so you could do still generic compression on both of that.
But you didn't try.
We didn't check that, no. Will, of course, both be smaller in total size, I guess. Yeah, sure.
But the compression ratio probably is comparable then.
So by the way, in the we're planning also to put these numbers on the GitHub then. So some of them are already there. It's not directly in the Zero GitHub. It's in the NDS EV organization. There is like there is Protobuf benchmark repository where this information. It's not complete yet. It's only covers a couple, but we'll update it soon also to get all the numbers in there.
Okay, seems
good. Thank you.
Questions have been answered. Thanks a lot, Fabian. And also it shows that this is a relevant topic. Yeah, good that you explained it like this.